This video looks at the concept of an inverse tangent. You've been introduced to the tangent function. Remember, we looked at the sine, the cosine, and the tangent function. We're interested in the inverse tangent function because it's very useful when solving problems involving angles of depression, which you will see in subsequent videos. But let me explain the main idea. If the tangent of an angle theta is equal to a, where a is some constant, some number, if you wanted to find theta, so you wanted to have an expression theta equals something, all you have to do is take the inverse tangent of both sides. So take the inverse tangent of the tangent, and that essentially reverses what the tangent does and gives theta. But whatever you did to the left hand side of an equation, you also have to do to the right hand side. So if you take the inverse tangent of tan theta, you also have to take the inverse tangent of a on the right hand side. And here we have the expression for the inverse tangent, tan to the -1. That's essentially the symbol for the inverse tangent. But that probably didn't make sense, but it will shortly when I use this a simpler illustration. Now you know that if you have a number like 3, so 3 is the starting number, I'll just note that down. So I'll note that down in an S. 3 is the starting number. If I add 2 to 3, I get 5. 5 here is the number we end with. So what have we done? We've just carried out the addition operation. In fact, we added 2 to the starting number to give the ending number 5. What if you want to undo what you just did? What do you want to go back from 5 to 3? Well, you have to do the inverse of addition, which is subtraction. So we added 2. So now we're going to subtract 2 from 5 to give 3, which is the starting number. I'll use another illustration using multiplication. Now, if I have a number 3, I'll use 3 again, the starting number. If I multiply 3 by 2, I get 6. So I end with, my ending number is 6. If I want to undo what I just did, if I want to do multiplication, I have to do the inverse operation of multiplication, which is division. So I start from 6, I divide by 2. Instead of multiplying by 2, I divide by 2, I do the inverse, and I get 3, the starting number. The same way subtraction is the inverse operation of addition and division is the inverse operation of multiplication, is the same way the inverse tangent is the inverse operation of the tangent. So the name is a hint. So just like how I started with a number, got to an ending number, and I then used an inverse operation to get from the ending number to the starting number, the inverse tangent can work the same way. So imagine you have an angle theta. I'm going to carry out an operation of theta. I'm going to take the tangent of theta. So this is what I have now. So this is what I started with, and this is what I ended with. Now I want to go back from the tangent of theta to theta. So what do? I take the inverse tangent of the tangent of theta, and that gives what I started with, theta. You can think of this is not mathematically valid, but you can think of the inverse tangent as cancelling out the tangent, just leaving theta. That's a way to think about it, but that's not how it works. It reverses the operation. It's the inverse operation, just like how subtraction is the inverse operation of addition. So if you have an expression like tan theta is equal to, I'll give you a number like 0.4. If you want to find what theta is, take the inverse tangent of tan theta. Doing that gives the following. Because I took the inverse tangent of the left hand side of this equation, I also have to take the inverse tangent of the right hand side term, and this gives, well, you can think of inverse tangent as cancelling out the tangent, but that's not actually what happens. But doing that leaves theta is equal to the inverse tangent of 0.4, and that's just the main idea. Now this inverse tangent of 0.4 can actually be evaluated using a calculator. All you have to do is push. If your calculator is anything like mine anyway, a Casio FX83 GT Plus, all you have to do is push the shift button, push the tangent button, type in 0.4, and push the equals to sign to get your numerical value. Now doing that on my calculator gives me 21.8. So check to see that when you find the inverse tangent of 0.4 on a calculator, In degrees mode, you get 21.8. I'm gonna just tell you a short story. So there was a girl who had a younger brother. She knew he was a big football fan. So on his birthday, she got him a brand new football. The boy really liked the ball and he played with it every single time. Played with it so much that he wouldn't even let his sister have a go. Anytime she asked, he said no. And one day, he had to go to a friend's birthday, so he had to leave the house and he couldn't take the ball. But his sister was at home and she said, "Oh, now's my chance to play with my brother's ball." And she then took the ball outside and started to kick it about and kick it, and she was just enjoying herself. And unfortunately, she kicked the ball and it flew so high that it went to the top of a tower. And that's the end of the story. So apologies for the childish nature of the story, but I'm trying to get somewhere. The girl is somewhere here at this point in blue. She kicked the ball to the top of the tower here. And she just stood here and looked upwards. She looked at the ball because she couldn't get it, but she was just looking at it in shock. Now, the girl is standing on the ground. So the ground is a horizontal plane level, represented by this black horizontal line. And then there's a tower here. This vertical line represents a tower. The ball is on top of the tower, and the girl is standing here looking upwards at the top of the tower. Now, this line here, this dotted line here, represents her line of sight. The angle formed between her line of sight and the ground level is known as her angle of elevation. Because if you think about it, imagine the girl was this dot. So I'm representing a whole human being as a dot. That's allowed in maths. It's just a simple case of modeling. Imagine she was looking straight ahead. Imagine she looked slightly upwards. Well, the angle formed when she looked straight ahead and the angle formed between her line of sight when she looked straight ahead and the line of sight when she's looking straight at the ball is her angle of elevation. And that's this angle here. I'm going to call it theta. So the angle of elevation essentially can be defined as the angle formed between a horizontal line of sight and the actual line of sight, or someone or a person, or an observer rather, on the ground level looking at an object that is at a height above the ground level. So I'll take that again. An angle of elevation is the angle formed between a horizontal line of sight and the actual line of sight of an observer at some point on the ground looking at an object at some height above the ground. So here we have the angle of elevation. So that's all you need to know about an angle of elevation. Now we're going to solve problems that require us to either find angles of elevations or find the height of some object above the ground, or the distance between an object at some height above the ground and an observer on the ground. Now, to solve these kind of problems, you just need to know what an angle of elevation is. You need to know SOHCAHTOA, which is the acronym for formulas for sines, tangents, and cosines of angles. And you also need to know Pythagoras' theorem. So we're going to apply all these theories and laws and rules that I mentioned to solve problems involving the angle of elevation. So here's the first example. And it says, a boy standing at a point A on the ground is looking at the top of a pole. So a pole, in this case we're referring to a vertical pole, and the pole is at point B. That's what it says. It says the base of the pole lies 10 centimeters away from the boy. And it says, the question goes on to say, sketch a right angle triangle that represents this scenario and label the angle of elevation. So let's just first draw the ground level. That's this line. A boy stands at a point A on the ground, and he's looking, so his line of sight is upwards because he's looking at the top of a pole. So I'm going to draw this pole here. So this should be a vertical line. He's looking at the top of a pole, so this is where he's looking at. And the pole, well, the top of the pole is point B. And he goes on to say the base of the pole, this is the base of the pole here. I'm going to call this point C. The base of the pole lies 10 centimeters away from the boy. So this distance here is 10 centimeters. all we need to do is sketch a right angle triangle that represents this scenario. And here we have a right angle triangle. So the pole is taken to be vertical, and for a horizontal ground, a vertical pole will be perpendicular to the horizontal ground. So we have a right angle formed here. So we have sketched a right angle triangle representing the scenario described. We have a boy here looking at the top of a pole. So here's the pole here. Boy looking at the top of the pole, point B, and the boy stands 10 centimeters away from the base of the pole. The question also requires us to label the angle of elevation. So the boy is standing here. This is essentially a horizontal line of sight. Imagine he was looking straight ahead, and this is his actual line of sight. The angle formed between a horizontal line of sight and the boy's actual line of sight is the angle of elevation. So I'm going to call this angle of elevation theta. Theta is the angle of elevation. So this is just a warm-up to proper angle of elevation problems, but at least you can see that it is related to what I've been talking about. All we had to do here was represent the problem using a right angle triangle and then identify the angle of elevation. You will find that essentially all problems involving angles of elevation will require you to sketch a right angle triangle. So here's a neater sketch of the problem. Here we have, here we have the boy at the point. This is a line of sight, and he's looking at the point B on top of a pole. Here's the pole, and this is the base of the pole, and the boy lies 10 centimeters away from the base of the pole. So the distance between the boy and the base of the pole lies on the ground, of course, is 10 centimeters. So here you can see the right angle triangle because the vertical pole is obviously perpendicular to the horizontal ground level. So this is the problem. And of course, the angle of elevation is this angle here, formed between the line of sight of the boy and a horizontal line of sight. So the line of sight of the boy and the line of sight if the boy was looking straight ahead. So it's looking straight ahead here or looking upwards. The angle formed between the two lines. So that's it. Here's another example question. It says, a boy standing at some point on the ground is looking at the top of a pole. A boy is on the ground and is looking at the top of a pole. The pole will be taken to be a vertical pole. The base of the pole lies 40 centimeters away from the boy, and the pole has a height of 30 centimeters. So that's the information we've been given. The first question says, sketch a right angle triangle that represents this scenario and label the angle of elevation with the symbol theta. So this first question is similar to the question in the previous example. We have a ground level. We have a boy standing at some point, and the boy is looking, so his line of sight is upward. He's looking at the top of a pole. So if the pole is here, the boy is looking at the top of the pole. The base of the pole, which is here, lies 40 centimeters away from the boy. But this distance here is 40 centimeters. So if I call this point A, call this point B, call this point C, this distance from point A to point C is 40 centimeters. The description also says that the pole has a height of 30 centimeters. So this is the pole, BC is the pole, and it has a height of 30 centimeters. And of course, the pole is vertical, so the angle formed between the pole and the horizontal ground is a right angle. And the file also says label the angle of elevation with the symbol theta. Clearly the angle of elevation is this angle here because the boy is here and he's looking upward. So imagine he was looking straight ahead. He has to rotate his head by an angle equal to this angle of elevation to be looking upwards at the top of the pole. So here we have the angle of elevation. I'm going to label it with the symbol theta. The second question says use SOHCAHTOA to determine the angle of elevation. So I'm just going to move on to a neater sketch of the problem. So here we have the boy here. We have the pole of height 30 centimeters. And we have the base of the pole here. And the distance between the boy and the base of the pole is 40 centimeters. We're required to use SOHCAHTOA to determine the value of angle of elevation theta. Now let's just observe a few things. For this angle of elevation theta, the side opposite to the angle of elevation has a height or length of 30 centimeters. The hypotenuse is this side. So the remaining side is the side adjacent to the angle theta, and that has a length of 40 centimeters. From SOHCAHTOA, you know that the tangent of an angle, so the tangent of, in this case, theta, is equal to the length of the opposite side divided by the length of the adjacent side, which means the tangent of theta is equal to 30 centimeters divided by 40 centimeters, which is the same thing as 3/4. 0 cancels 0, centimeters cancel centimeters. So tan theta is 3/4. So just by looking at a triangle and using the TOA bit of SOHCAHTOA, we've gotten this equation: tan theta equals 3/4. Theta is the angle of elevation. We're looking for the value of theta. How do we get theta when we have an expression like this? Well, we take the inverse tangent of tan theta to get rid of the tangent. And because I'm taking the inverse tangent of the left-hand side of this equation, I must do the same thing to the right-hand side of the equation to preserve the equality. This gives theta, so you can think of this is cancelling this, even though that's not what happens. And theta is equal to the inverse tangent of 3/4. And you can determine you can evaluate this expression by using your calculator. So first push the shift key on your calculator, then push the tangent button, and then type in 3/4 or 0.75, and then push the equal to button, and you will get that theta is equal to 36.9 degrees. Here's another example question. It says a football located at a point A, obviously on the ground, which is on the same level as point B, is located 173 centimeters from point B. So a football is located 173 centimeters from point B and is also on the same level as point B. Point C, another point, which lies on the crossbar, so the goalpost, the crossbar, is located 300 centimeters directly above point B. Determine the angle of elevation of point C from point A using the given sketch. So here's the given sketch. You have a ball A located 173 centimeters from point B. Point A and point B lie on the same level, so the same ground level. Point C, which is on the crossbar, the goalpost, the top horizontal pole on the goalpost, the crossbar. The point C lies 300 centimeters above point B. So this is centimeters, let's put it that way. So essentially, we have this, and we're given this right angle triangle that represents the problem, because if you think about it, if someone is at point A here, they could be looking at the point C. And if someone stands here at point A and is looking at a point C, the angle of elevation from point A to point C is this angle theta, because someone is standing at point A, and if imagine they're looking horizontally, their line of sight will be this dotted line. But if they're looking at point C, the line of sight will be this line here, and the angle of elevation is the angle formed between a horizontal line of sight and the actual line of sight. So that's this angle here, theta. So what we have here is a right angle triangle, and all the question is asking us to find is this angle of elevation theta. We just need to find an angle of a right angle triangle. Now if you observe, the side opposite this angle theta has a length of 300 centimeters. Well, let's stick to that. And the side opposite the right angle is the hypotenuse, so that's this side. So the remaining side is the side adjacent to angle theta, which is the side with a length of 173 centimeters. So essentially what we have is a scenario where we have a right angle triangle. The length of the opposite side to the angle we're interested in is 300 centimeters. The length of the adjacent side, so A for adjacent, is 173 centimeters. And we know from SOHCAHTOA that the tangent of the angle theta is equal to the length of the opposite side divided by the length of the adjacent side. So replacing O with 300 centimeters and A with 173 centimeters gives this. So essentially what we have is that tan theta is equal to 300 over 173. So cm cancels cm. If you simplify this with your calculator, you get tan theta is equal to 1.73. And we are looking for theta, the angle of elevation. So what you have to do is just take the inverse tangent of tan theta. Because you do that to the left hand side of this equation, you have to do the same thing. You also have to take the inverse tangent of the right hand side term. Simplifying the left hand side gives theta, so you can think of this as cancelling this, which is not actually what happens, but that's a good way to think about it. So theta is equal to the inverse tangent of 1.73, and to evaluate this expression, all you have to do is push the shift button on your calculator, then push the tangent button, then type in 1.73, push the equals to button, and you get your result, and you get that theta is equal to 59.97 degrees. And that's our angle of elevation. So it's the angle of elevation from point A to point C. So you just imagine someone is standing at A and looking at point C. Here's a final example question on the topic of angles of elevation. So here we have the following. In a certain region of a wildlife reserve, so a wildlife reserve will be a place where you can find a variety of animals. It says that two monkeys are staring at each other. Monkey A, the first monkey, is located at a point A on the ground. So in fact, I'm just going to start sketching this. So this is the ground level, and monkey A is somewhere here on the ground, point A. Whilst monkey B is located at a point B on a tree. So if I draw a tree here, put monkey B on the tree, and we go on to read that monkey B is 20 meters above the base of the tree. So here's the base of the tree, and it says that monkey B is 20 meters above. So the height from B to this point, I'll call it C, BC, is 20 meters. And it says the angle of elevation of point B from point A. So we're looking from point A. So the angle of elevation of point B from point A, so we're looking from A, is 70 degrees. So this angle here is 70 degrees. And it says, then the question goes on to say, determine the distance from the base of the tree to monkey A. So we need to find this distance. I'm going to say let this distance AC be X. So we need to find X. So I'm just going to show you a neat sketch of the problem, which is what we have here. So we have monkey A here, we have monkey B here. The angle of elevation from A to B, or rather the angle of elevation of point B whilst looking from point A is 70 degrees. The height of B above the base of the tree is 20 meters. And we need to find this distance X, the distance between point A and the base of the tree, which I'm going to call C. What we have here is a right angle triangle. You have the angle 70 degrees, and we have the side opposite to the angle 70 degrees, which has a length of 20 meters. So I'm going to say O is 20 meters. This is the hypotenuse here, the side opposite the right angle, and the other side here with length X is the adjacent side. And we have the angle theta is 70 degrees. From SOHCAHTOA, we know that the tangent of an angle, so tangent of theta, is equal to the length of the opposite side divided by the length of the adjacent side. So the tangent of 70 degrees is equal to O, which is 20 meters, divided by the length of the adjacent side A, which is X. So cross multiplying, or let me just first rewrite this as tan 70 degrees over 1, which is the same thing as tan 70 degrees. So cross multiplying gives X times tan 70. So I'm just going to put tan 70 in the bracket, equals 20 times 1, or 1 times 20, which is 20. So dividing both sides by tan 70 degrees gives the following. You know that tan 70 degrees in tan 70 degrees will be 1, because something divided by itself is 1. So we have X times 1 over 1, which is X, equals 20 over tan 70 degrees. Now from your calculator, you can work out that tan 70 degrees, the tangent of 70 degrees, is equal to 2.7474. The reason why I've written the tangent of 70 degrees to 4 decimal places is just so that I can get a very accurate result. Now in the final result, you see that I don't use 4 decimal places, I use just 1 or 2 decimal places. So let's see, since tan 70 degrees is 2.747, and just in case you can't work it out, to find the tangent of 70 degrees, just hit the tan button on the calculator and then type in 70 degrees and hit the equals to sign. But make sure your calculator is in degrees mode. And doing that gives x is equal to 20 divided by 2.7474, which you can work out on your calculator to be approximately equal to 7.28 meters. So x, the distance we're looking for, is 7.28 meters. And that's the solution to the problem.